So good evening, everyone. Thank you for joining us for our Environmental and Geological Engineering Ask Me Anything. My name is Kelsey. My pronouns are she, her, and I'm the undergrad recruitment coordinator for the Faculty of Engineering. I will note that this webinar is being recorded and it will be emailed out to all of the registered participants within a week or two after the presentation. There were lots of people registered for the webinar, so hopefully everyone will get a chance to take a look at it, but I will dive right in as we have a lot to go through. So just some housekeeping notes here throughout the webinar. We encourage you to submit any questions that you have through our Q&A function on your screen. So there is no chat option. So if you just click the Q&A, you can submit your question and our experts on the call will be more than happy to answer any of the questions that you have. You also have the option for closed captioning if that's something that will help you out. So just click the more and language and turn on live captions. If you have any questions after the webinar or any questions that don't get answered, please email us at enginfo@uwaterloo.ca and we'll be more than happy to answer any questions you have. But first, I just wanted to give the University of Waterloo's territorial acknowledgement. So the University of Waterloo acknowledges that much of our work takes place on the traditional territory of the neutral Anishinaabe and Haudenosaunee people. Our main campus is situated on the Haldimand Tract, which is the land granted to the Six Nations that includes 6 miles on each side of the Grand River. Our work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and is coordinated within the Office of Indigenous Relations. You can visit native-land.ca to learn more about the land you occupy. So we have a lot of our experts on the call. So we have Shundi, our Director of Geological Engineering. We have Monica, a Professor and Associate Director. Also have a current to-be Environmental Engineering student, Brianna, and we are joined by Kyle, who is a Geological Engineering alum. So first, I will pass it off to Shundi.
All right, good evening, everyone. I'm Shunde Yin. I'm the director of the Geological Engineering program under the Department of Civil and Environmental Engineering. I'd be happy here to share some of the perspectives as related to the geological engineering. First of all, I'd like to point out that the geological engineering and the environmental engineering do share some common contexts, such as the sustainability and the hydrogeology. And then the environmental engineers involves working with the hydrosphere, biosphere, and the atmosphere, more in the air and the water, this kind of subjects. But the geological engineers are more involving the lower and the hydrosphere and the lithosphere. In other words, we are more dealing with the rock, soil, and water. So the overlap is kind of the water with the environmental engineer. And particularly geological engineering is the application of the geological knowledge to the setting, the design and construction, operation and maintenance of engineered structures and facilities. It's one of the rapidly growing emerging fields of engineering, reflecting society's developing interest in the stewardship of the environment, managing risk, and creating a safer world. What does a geological engineer do? So we basically design the safe infrastructures, including dams, reservoirs, pipelines, roads, railways, and the buildings. Another major task for the geological engineers are develop energy and natural resources. And these are related to the hydropower, mining, oil, natural gas, groundwater, and some minerals, as well as the renewable energy that's related to the solar, wind, and geothermal energy. Lastly, the geological engineers deal with the assessment of the geohazards, such as landslides, earthquakes, volcanoes, and the stability of natural dams, and some other underground infrastructures that you're going to see in some slides later. Geological engineers learn the fundamental engineering skills and the foundation of earth science knowledge. We have the components of lab and the field courses, Particularly the field trips are the feature of the geological engineers because they have to touch on the rock and the soil and water to learn looking at the nature of these subjects. And this lab and the field experiences bridge the gap between the theory and the practice, allowing our students to see the geological processes firsthand. These are the core courses the geological engineers take, such as the calculus and differential equations, fluids, probability statistics, computational methods, geotechnical engineering. These are the related to engineering. On the other hand, this program is co-sponsored by the Faculty of Engineering and the Faculty of Science. On the science part, we have the core Earth Science courses offered by the Department of Earth Science. In those contexts, we have the structural geology, rock mechanics, engineering geology, mineralogy, stratigraphy, and Earth history to be taught, looking at the 5.5 years of the program. Within this program, you can also have some specializations if you have particular interest in the geology, hydrogeology, or the soil, rock, and structures. And some other options are offered in the elective courses. You might have some other interest in the artificial intelligence, and lab physical science, and etc. Some typical industry or geological engineers will end up at will be the oil, gas, utility industries. They are more like the energy or energy resources related. Next major industry is the mining or mineral resources industry. Then it's going to be the construction, design, and the survey, more or less overlapping with the civil engineers. Some emerging industry like the renewable energy, such as geothermal, wind and solar, also or target industry for the geological engineers. Of course, municipal and the provincial governments. We have the civil engineers, geotechnical engineers, and geological engineers. So that's our other areas. In carbon sequestration, we probably have heard of the greenhouse gas and the climate change. Those things are related to the geological engineers as we are going to have the carbon sequestration task to mitigate those kind of climate change due to the greenhouse gas. We also deal with the environmental and earth science industries, overlapping with the environmental engineers. That you're going to hear more about that that kind of roles when the Professor Monica that will be describing later on. Of course, some of our students will be moving up to the graduate studies. We are also going to be eligible to have some professional degrees after our 4 years program. Some typical areas of the study as reflected in some pictures. This is like related to the infrastructure. We are responsible for the stable and sustainable and resilient infrastructure such as the road and the bridge and the dams. Some underground infrastructures such as the powerhouse of the hydropower and the dam systems. As a geological engineer, we want to make sure that this rock excavation activities are carried out in the safe way. We want to make sure our powerhouse will be maintaining the stable status for 100 years. And some other underground infrastructure will be like the underground storage space for the nuclear waste. We basically are expecting to store those nuclear waste permanently in the underground rock at the depth of about 600 to 700 meters, which basically in the certain type of rock. Because these nuclear wastes are going to be releasing heat continuously, that's going to affect the behavior of the rock. And indirectly, it's going to be affecting the hydrogeology as well. So it's our geological engineers' task to handle this kind of risks that are related to this kind of nuclear energy. Another part of the industry is related to the emerging renewable energy industry. For example, if we have the wind and the solar energy, a big problem is about the mismatch between the power supply and the power need. Sometimes the wind is blowing hard, but we don't need that much power. In this case, we might have some storage facility to store the excessive power. One thing that we can do is to use the surplus power to generate certain chemical gases such as hydrogen. Sometimes we can use this surplus power to compress the air, creating certain high energy gas and inject them under the ground. And when we are needing more power, we can release this kind of high energy gas from the underground. The advantage of this type of energy storage for the facilitation of the renewable energy is they can sustain a large scale of the energy storage. For example, in an extreme case, we could be even moving the heat from the summer to warm our house in the winter. And in turn, we can move this cold energy from the winter to cool our house in the summer. So that's kind of the concept of the energy storage. This kind of energy storage cannot be implemented by those battery energy storage facilities that we usually have heard looking at from the media, because it can only sustain a few hours of energy storage. But to sustain this kind of large-scale energy storage, the geological energy storage is the only feasible way. And geothermal energy is another big part of the renewable energy. As a geological engineer, we are basically responsible for designing the proper development scheme to develop the heat from the underground to generate power using those kind of turbine and generators. And we could also use those heat or thermal geothermal energy resources under the ground to heat the road, to melt the ice, and for some other the usages. The geothermal is a big part of for the geological engineer because it's very close to our life and is providing the constant energy supply in comparison to those other type of renewable energy such as the solar and wind, which is kind of intermittent. And another word of the geological engineer's job is in the mining or mines. Look at this diagram. It's associated with a salt cavern in Windsor, okay, in southern Ontario. If you look at the picture on the right, next, uh, and that's going to be, this is one of the world's largest underground mine that is producing okay, the salt, the table salt, and also the salt that we use to melt the ice on the roads. Ontario has lots of such mining resources, and the space actually left behind the mines can be used for the energy storage purpose that we have shared earlier. So in Ontario, we do have a lot of energy resources. We also have the underground space to accommodate those kind of energy storage purpose. With that, I'm going to pass over again to Professor Monica to provide you some perspective about the environmental engineering.
Thanks, Shundi. So good evening, everyone, and everyone online who will be watching this when it's recorded. My name is Monica Melko, and I'm the Canada Research Chair in Water Science, Technology, and Policy. So obviously water is what I'm interested in. But I'm really happy to have the opportunity to speak with you tonight about our environmental engineering program. I used to be the chair of undergrad studies, and so I have a lot of familiarity and love for this program. So let me tell you a little bit about it. Environmental engineering. Environmental engineering. It is so many things to so many different people. And one of the things you're going to hear about is because there are so many routes you can take in environmental engineering, we have some exciting changes coming up in the program as of this fall. And so I'll get to those in a minute. I don't want to get ahead of myself. But I think the easiest way to describe what an environmental engineer does is to say that environmental engineers work at the interface between humans and the natural world that we live in. We have to interact with it. So we're found in industry, we're found in government, we're found, of course, in the research world. Anybody who interacts with the world, any corporation needs to interact with environmental engineers. And we have this dual responsibility that we have to design systems, whether they are very natural resource based or very technological, but we have to design systems that improve both the well-being of humans and also the health and resilience of the natural systems on which we depend, right? It's about that give and take between the natural and built environment. And so you'll see some engineers more in the built environment, some engineers more in the natural environment, but anywhere where that intersection exists. So let's talk a little bit about what we do as environmental engineers. So I think more than ever, as we're in currently, I'm in balmy Ontario where it's really warm and it's basically almost December and we haven't seen snow yet, here anyway. If you're in Calgary, that's completely different, I realize. But more than ever, we're all realizing that there is such an urgent need to develop engineers that are equipped with the diverse skills that are necessary to solve the problems that climate change and continued resource development are creating for future generations. These are the big challenges that we're all aware of, whether it be fires and smoke and implications to health and implications to resources and our water supply, the loss of species, issues related to biodiversity, flooding, heat waves, droughts and the implications for our food supply and for ecosystems. And then, of course, constantly growing populations and trying to balance development, where we live, where we recreate, our landscapes that have spiritual value, and of course, our natural ecosystems. These are all the issues that require balancing, that require, for management, environmental engineers. So there are so many ways that somebody can get involved in addressing these challenges if they're an environmental engineer. So how can we help? How can you help in becoming an environmental engineer? Well, let's start talking about the opportunities. So let's talk about what's more traditional or conventional about environmental engineering. Of course, over the years, over the centuries even, there have been crises, there have been necessary issues that we've had to manage in between how we interact with our landscape. So we can think about waterborne disease. With the advent of water technologies from the 1900s, moving into the 2000s, 4 of the major causes of death have changed because of environmental engineers and the technologies that we have for basic hygiene and sanitation. There's issues of flooding, air pollution, management of waste, etc. All of these systems have to be designed and then implemented, then managed, and then ultimately improved, because we constantly need to improve. We're having on a regular basis, looking back and seeing not only continual improvement, but increasingly stringent standards. We're learning more about the impacts of various compounds like microplastics. 20 years ago, people thought microplastics weren't a big deal, and look where we are now. So we're constantly managing these systems. And we're also developing new environmental systems and dealing with new challenges. And so this is where the old becomes new with the microplastics, but also looking at issues such as river restoration, looking at wetlands, quality in these systems, trying to balance species diversity and saying, well, which species do we value? What trade-offs are we looking at? We're also looking at how to limit emissions and sequestering carbon to reduce atmospheric carbon dioxide to manage global warming, right? And how can we extract resources from our waste to create a circular economy? So can we have waste-driven energy sources, for example? We need systems that can do this, and we need systems that can do this on a scale that's actually going to be meaningful in society. We also need to be prepared to deal with the problems that we're not fully aware of yet. We need to be better monitoring and modeling our natural and engineered systems to identify problems and start working on solutions as soon as we can and far, far before they become an actual crisis. And I think one of the greatest challenges that we're facing is that the past can no longer be relied on to predict the future. So we are preparing for a future unlike the past. That is the position climate change has put us in. It's this idea of non-stationarity. You can't rely on the past to predict the future. A 100-year flood is no longer a 100-year flood. I'm sure you've heard that in the news, right? So when we have this uncertainty, when key factors like rainfall patterns are changing, when winter is changing, summer heat waves are changing, plants and animals are moving, we're having fires where they didn't occur before, we're finding new pathogens in our water supplies. We need to rebalance our relationship with the natural world, and there is so much to do. We need people who have a very diverse set of skills and can communicate that science into action. That's why we need more environmental engineers. And that's how you can get involved. And so I'm thrilled to let you know that we just learned in the last few days that the University of Waterloo is ranked first in an aspect of environmental engineering globally, the water resources area, which is based in engineering. It's a key aspect and a strength for our department. So it's really exciting to hear that news. And I think I said first in the world, and I meant first in Canada, amongst the top in the world, because I'm a keener and always aiming higher. But it's great to be among global leaders in that regard. And that's not where we're stopping. We're actually reimagining our environmental engineering program. And really, that is out of need. Over the past few years, we've been thinking a lot about the program and really looking to make sure that our students have a clear pathway to addressing the multiple challenges the world is facing. And you can see in the bottom right corner, we're talking about some of the challenges that have been identified as Canadian engineering grand challenges: safe and sustainable cities, resilient infrastructure, safe water in our communities, one of my passions, and sustainable industrialization. And you can see on the left side of this slide that those are very closely linked to the United Nations Sustainable Development Goals. And several of them are listed here that our program connects to. Again, sustainable cities and communities, climate action, responsible consumption and production, and also clean water and sanitation. And arguably, the work that we do actually extends even beyond those to the next tier, such as making sure that there's equity more broadly in the world, and also issues like health. If you think of, for example, waterborne disease as one example. So that's what we're looking to target. So how have we changed the program? So we've been thinking about this, and really what this has come down to is recognizing that there are many flavors of environmental engineering, many potential pathways. So if you take me, for example, my interest is public health and protection through safe water. That's very different than, say, looking at alternative energy sources. And so in the future, in 2025, so next year, we're launching a revamped program that includes new courses in first and second year to really get to some of those environmental engineering fundamentals. And then also bringing in a design studio style course to work on these open-ended challenging problems right out of the gate in year one. And so we have this design studio going through all of our years. And then we have a series of specializations to show you a path to some of the key careers that you might be interested in and the challenges that you might want to address. And I'll talk about those in one more slide. But first, let's talk about what environmental engineers learn. So in our classrooms, you will see a range of type of teaching styles and course contents. You might be out in the natural environment in the field. You might be doing chemistry, biology. You might be in the hydraulics lab, the computer lab, using artificial intelligence, doing geomatics and geoinformatics. You name it, there are tools that we have to access from large landscape scale, watershed or continental scale processes, all the way down to micro and molecular scale, work with pathogens, work with various compounds for treatment, et cetera. So a range of scientific scales. And of course, mathematics is the language we use to make that science work. One of the most exciting attributes of our program is the final year capstone design aspect, where you have a year-long project in an area of your interest and your choosing, and you work with a team. Examples include sustainable river restoration projects to mitigate flooding, designing alternate energy and water harvesting strategies for remote communities, wetland design for water quality treatment, wastewater sludge for hydrogen fuel use. One of the groups I'm supervising this year is looking at mitigating wildfire impacts on water quality and treatability so we have safe drinking water. There's an endless supply of environmental issues that need to be addressed. And fourth year design actually is a lot of fun because you can really start to put those skills to use. And so this slide has one of those, some of those key features for the new year that I was talking about that we're really, really excited about. And so one of the main features of the new program is the idea of specializations. So this program is basically in the last stages of being approved through our university. So we know there's going to be this opportunity for students in the future, in the very near future. And this idea of specializations, what it gives you is it gives you a line of sight for, if I'm interested in working in this area, what courses might I be able to take and will they be available? One of the really neat attributes of these different specializations that you can see here is that they are not only based in our program, but they necessarily link to other programs or departments within the Faculty of Engineering, and then also across campus. You have to have a pretty diverse set of skills to be a successful environmental engineer. So it's not just a little bit of math and science, but then it's putting the pieces together, solving the problems, and most importantly, to make change, communicating them. And so we have an environmental, in the environmental program, we have an energy and climate change option that really looks at these issues of carbon sequestration and alternative energy. We have resources. So where is water moving? How much of it is it? And when are we going, is there on the landscape? And when are we going to see it? How can we mitigate flooding? If you're interested in water quality, whether it be for ecosystems or for public health protection, we've got the pollution and restoration specialization. And then we have a modeling and data analytics specialization. And we're actually imagining that many people might be interested in one or two specializations. And so you can imagine taking modeling and data analytics, the mathematics, and decision-making aspects of any of these more science-driven specializations. The last specialization in the environmental program really builds on our roots as a broader civil program, and it really gets into how can we make cities more sustainable. And so we imagine that many of the students who take that specialization will be wanting to connect into aspects of architectural engineering and building design, or civil engineering, road design, structural design, et cetera, and beyond as well. So a lot of different pathways for different interests and focusing on solving different problems. So specializations are within the program. Options are open to anybody across campus. So you can also take an option outside of your program. So an example of a popular option is artificial intelligence. It's put on by the faculties of engineering and math. And so people from across campus take that option. There's also a business and entrepreneurship called entrepreneurship option. There are life and physical sciences options, management options, statistics, math, you name it. There are many options at the University of Waterloo. One of the other key features, of course, of your program is electives. What can I take? And there are so many upper year electives. In fact, in our programs, almost all your courses in your 4th year are electives. And so again, you can really pursue those topics that you have a passion for. So again, all compartments of the environment, air, water, and land, the various sciences they connect to as well. You can see some of the courses listed here, a lot of technical electives to choose from. So finally, what do environmental engineers do after they graduate? What kind of career paths do we follow? Well, how much time do you have to discuss these? You name it, people are pursuing it. Many people do, in fact, stay, many of our graduates stay in the environmental engineering and civil engineering kind of those broad areas. Discipline, many of them work in consulting, providing advice to other businesses, communities, individuals. Some people go on into the private sector, energy, renewable resources, green technologies. Absolutely, we see people in the municipal and provincial government sectors, also federal government, Environment Canada, Health Canada, various federal services, moving on into artificial intelligence, software development. The biggest AI-driven water company, and I'm trying to think of how to describe it, but because it's evolved, has been bought out twice now. Started off by being developed by Waterloo grads. There was a company called Imagine, and it was the first really AI-based water sector company that really has had international reach. We have graduates who go on to into manufacturing, public health, something I've spoken about, also development, international developments such as the World Bank or the United Nations. But what's really interesting, and some people don't realize, is we have plenty of graduates who actually don't stay in areas that are really closely related to engineering, and that surprises people. But engineering teaches you how to solve problems. And so you might not be surprised, perhaps, or you might be, to hear that some of our students go into financial sectors, banking. They might pursue MBAs. They've got those analytical skills to pursue those jobs. Of course, we see some of our students going into graduate studies, but we also see within engineering, we also see outside of engineering students pursuing medicine, a lot of law, environmental lawyers, and like I said, a lot of MBAs because of the analytical skills, the mathematical skills that people have. So very widespread. Another area would be strategic management consulting as an example. And again, that's problem solving. So an engineering degree is a solid degree from which you have a basis to go in many directions depending on wherever your passion is. And so I'm obviously excited about the environmental engineering program and really civil and environmental engineering department more broadly, including geological engineering. But of course, that's my take on it. If you really want to get a sense of our programs, probably the best people to speak to are our students. So on this note, I am going to pass this off and give you a chance to listen to some of our students and what they have to say. Thanks.
Thank you. We just had a couple slides here. Well, Monica or Shundi got a couple more slides before the students chat.
Oh, I'm sorry. I can do this.
That's okay.
I just would suggest that the students are who you want to hear from. But let me go ahead and do this. I apologize. So this is an important slide, and I think our students can speak to some of this from their perspective, but I will go ahead and kick us off. One of the first points that is really important to know, which isn't on this slide, is we read your applications. And related to that, we have small class sizes. And now, why is that related? It's related because we like to know our students. We actually really read your applications, the AIF forms. We're very interested in knowing why students want to be here. We have small class sizes. We get to know our students. We have an open door policies. And really, that class size is the cohort, the group of people you move through your program with. The environmental engineering and the geological engineering students do move through the program together. not in every class, but in many of the classes. And so you really develop a really nice sense of community. As most of you probably know, if you've looked at applying to our programs, there is direct entry into our programs. So you are applying to a specific program, not just the University of Waterloo. And so it's important to put the program you're most interested in first. Yes, there are numbers and statistics, but I think a lot of people misinterpret those. Really, what we're looking for is people who want to be here and who have demonstrated capacity and interest in being here. One of the well-known and exciting aspects of our program is that we have co-op placements. We have the co-op program. In our programs, Environmental and Geological Engineering, you start co-op literally in January. So you start in school in September, you go to school for a term, then you're on co-op in January. It's great to break up the first year. You get a little bit of academic tools in your toolbox, and then you go out and you get that perspective, that applied perspective in the workplace. It really helps inspire and invigorate you, but also we're being strategic about that. In your first year, when you have the least amount of academics behind you in your undergraduate program, that is the fewest tools in your toolbox, we're sending you out to work in January. And what that means is you're not competing for jobs in the summer. We bring you right back in the summer. We put more tools in the toolbox and keep adding thereafter, leading to what we think are very competitive co-op students who have a very, very high success rate in getting placed. One of the other key aspects of our geological and environmental engineering programs is you're really learning, and you have to be learning across disciplines. These are multidisciplinary programs. There is every aspect of science that you can imagine. There is mathematics to make that science work, but there's also the communications. There's also the policy. There's also the psychology, if you will. And I'm not saying psychology is a foundational part of our program, but even the best technologies will fail if people aren't in a position to take them up. And so we need to learn to communicate to make sure that there is uptake of that technology, that there is uptake of, for example, climate change adaptation strategies. We are very proud of our program. We really value education. We have award-winning instructors. We have focused faculty exclusively in first year who are there to teach exclusively. Professors like me do research as well as teaching, and we also get involved in the administration of the university. We have award-winning teachers in first year that will be there. They offer extra tutorials, extra supports to make sure that everybody is making their way through the program. Another key part of our program that I touched upon previously is that we start getting our hands dirty from day one. And what I mean by that is we get right into it with design aspects, dealing with really challenging open-ended problems and developing the skills, because it's a set of skills that's associated with going through to the design process. You can have one design question and every student in the class can have a good answer, but it'll be a different answer. So there's a process associated with that. And we start emphasizing that with that design studio that I was talking about right from day one. And related to that, you can imagine there is a very strong integration of hands-on and classroom learning. And what that means is experiential learning. It's in the lab, it's in the field, it's in group work. You are learning to bring all of those skills together to develop whatever your technological output is. Another part of the program that most people are familiar with is that when you complete our programs, you qualify as a professional engineer for environmental engineering and geological engineering students, or you can also qualify as a professional geoscientist if you're in the geological engineering program. So many reasons why one should choose geological and environmental engineering, especially at Waterloo. That community, that small class size, the success of our co-op program, the hands-on experiences from day one, those are all reasons that we think we're really proud of and deliver this top program or these top programs to our undergraduate students. I will add one more to that category. I know, just as you flip the slides, one more piece of information to these bullets, which is really the supports you get from teaching assistants who are there to help learn. It's not necessarily a funding mechanism for those graduate students who help contribute to your education. But the other part of it is also tutorials early on in first year. So there's additional learning supports to make sure that you can keep up with your coursework. It's a tough and daunting education to look at from the outside, but once you get in, you'll find that there's a lot of supports here at the University of Waterloo. So really good reasons to come here. Sorry about that with the advancement of the slides. So these slides speak to the program. And so what you can see here is we have the two terms from first year. So we call them A and B usually. So in this case, it's the fall term in the first year is A, and then spring is 1B. And so you can see that co-op term interspersed, as I spoke about. And what you can see here is that the courses are very, very similar for both the geological engineering programs and the environmental engineering programs. Where you'll see a little bit of differentiation in the upper years is that the geological engineering program focuses more on those geotechnical and earth aspects or science aspects, whereas, excuse me, environmental engineering focuses more on environmental chemistry, biology, and air quality. And so the way I would differentiate that very simply is the geological engineering program is at the ground surface and below. And in general, the environmental engineering is at the ground surface and above. Are there overlaps? Absolutely, but that's a good way to differentiate between the two. And so not surprisingly, you see commonalities in the upper years. And as I mentioned previously, you will have multiple electives, at least 6 to 7, where you can really specialize. You can pick and choose in your upper years to pursue those topics of interest. It's also worth noting that we also have complementary studies electives. And so that's where you can go beyond the discipline of engineering and have courses that are driven by the breadth of issues you'd be interested in. Now, I should point out that the number of courses in general, the availability of electives is largely driven by our accreditation, because again, you can graduate, or when you graduate our program, you can be a professional engineer or a professional geoscientist. So we can't just offer you any courses, but as far as being within those constraints, we have a heck of a lot of electives and options for people to choose between for focus, and then so that depth, but then also the breadth. This is one of the most exciting parts of our program, which this idea of theory and practice, we like to get our hands dirty. So not only do you have courses in the classroom where you have traditional lecture style, or you're working at the computer, perhaps working on some code or some modeling, but we also have opportunities to test things in practice. So we've got lab courses, we have design days where we have, for example, design and testing of a dam and landfills. So we have competitions as well. We also have a lot of design teams at the University of Waterloo. There are a lot, and increasingly more industry-funded technical clubs and competitions that you can compete at the national and international level. Some of the examples are listed here, like Concrete Canoe, Habitat for Humanity, Engineers Without Borders, the World Environment and Resources Council environmental design competition, and just increasingly more and more where you can compete. You have a defined problem, and you see who can come up with the best prototype, the best solution. I'm really proud to say our students tend to do really well in these design competitions, and it's because they get their hands dirty early, and they're not afraid to fail, and they're not afraid to keep going until they don't fail. So it's a lot of fun. Field trips. This is another great part of our program. There are some pretty exciting field trips. This is the Earth and Environmental Science field trip to the Elora Gorge. There have been field trips to South America, depending on the courses you're taking. You can't be an environmental or geological engineer and not get outside and not see these processes in reality. And sometimes that means looking at a very large landscape. So several of our courses do offer field trips and those hands-on experiences, as you can see here. And at this point, I'm going to go ahead and ask Shundi if you want to jump in.
Yeah, thank you, Monica,
Yeah.
for the excellent introduction of our courses and the lab components and the field trips. Yeah, these are the some field trips for the rock mechanics and geological characterization, as we have to be familiar with the nature of the rock if we are going to design the safe underground infrastructure. We would like to align the theory that we learned from the class, like those different types of faults, with the natural real faults that we have seen again in the real world. In this field trips, we are going to learn the different type of bedding and the joints, different type of rock and the dip angle and the strike angle, all different type of the concepts that we've learned from the structural geology, stratigraphy, and rock mechanics. And yeah, we sent people to the some field trips to learn the rock from the all different type of the sites. This is a site that is related to the underground the powerhouse, as related to the renewable energy such as the hydropower. Yeah, we also have the field trip to some geothermal energy related sites. Like in this second figure, you can see our geological engineering student went to the Iceland, where there's a famous hot spring, where our students can have a real direct feeling about the geothermal energy. And yeah, we do have yeah, many experienced instructors who are award winners. From the right-hand side, you see this series of the instructors who have lots of experience in teaching or undergraduate students. You're going to be exposed to the courses and the classes that will be taught by these groups of excellent instructors. And the society, Kelsey, are you able to share some of your perspectives on this?
Yeah, thank you. I can chat about this and then we can hear from the students here.
Yeah.
Let's see if they are. That's our engineering society of the largest, most active engineering society. There's always something going on. We have award-winning student societies, we have resume critiques, professional networking, guest lectures. There's events and things that happen all the time, wellness and diversity promotion. We have a wide range of student groups. I know not everyone thinks that engineering students have time for extracurriculars, but I can confirm that most of our students are extremely involved, and hopefully we can hear from them and see how they've been involved. So we will now hear from current students. So I will pass it off to Brianna, and she will chat a little bit about her experience.
Thanks, Kelsey. Yeah, so I'm Brianna. I'm in my 2B term of environmental engineering, so my 4th study term, but technically my 3rd year here at Waterloo, and my pronouns are she, her. So a little bit about the co-ops I've had so far. Because I'm in my 4th term of study, I've had 3 co-op experiences so far. My first one was actually in construction. It was a field job, and I was working in Gatineau on one of the federal buildings. Everything I did there was so wide-ranged, but a lot of what I did was looking after heritage elements in the building to make sure that they're kept track of and they're logged properly. I got to see a lot of the original engineering drawings from the 1900s, which is really cool, as well as a lot of the art there and the woodworking. That was pretty cool. One of the pictures here is actually me going on a 200-foot tower crane, which was so cool, probably a once-in-a-lifetime experience. But this co-op I think was really great for me. I enjoyed it so much. It was really fun, honestly. But I got a really in-depth understanding of what goes on a construction site, what project management looks like, and also how a lot of environmental policies sort of play into construction in terms of, if you've ever heard of LEED standards and how sustainability can be brought into those construction systems as well. How you can consider the materials of what you're working with and how all that can be relevant. My second co-op experience was with the federal government, natural resources specifically as a research assistant. So we were working with biochar and biofuel and carbon sequestration. So a lot of what I was doing was sort of surveying what research has already been done, where the industry is at right now, and where we can start building in terms of clean energy, clean and sustainable energy. And also I was able to run trials with different reactors, just trying to optimize the yield and make the system a little bit more efficient. Since getting a broader education here, I've actually looked at a lot of different career opportunities, and I wanted to try out healthcare for my third co-op. And I thought that this position was going to be really difficult for me as an engineering student, just because it seems, untraditional and a little bit far out of our realm. But I think with, the perception that employers have of the Waterloo engineering co-op program, they were actually, ready to hire an engineering student. So that was really convenient for me. But basically at this job, I sort of did everything there. I did a lot of financial analysis because it was a small business. So a lot of financial analysis, sort of optimization of appointment scheduling and interacting with patients as well. A little bit of everything. So what I love about environmental engineering is just the fact that there are so many career options. I know you've heard a lot of them already in this presentation, but I have friends who have gone into co-ops and, there's energy, hydrology, consulting, environmental remediation. It just feels like whatever you're passionate about, there's a way to work that into your career. Also, specifically, I think it's difficult to find careers for people who are, really passionate about environmental impact, and in environmental engineering, it's definitely something that we focus on, especially with it being such a huge pillar in the Waterloo community to be focused on sustainability. Another thing that I like about my program is just the fact I've noticed it a lot this term in my 2B, but just how knowledgeable I feel at the end of the day, because we learn so many different subjects and so much about those subjects. It's so much more broad than I thought it would be going into this. We're learning a lot of, almost all the sciences, chemistry and biology, and air pollution. In these photos here, you can see the top left one is from my 1A term when we did field surveying, which is just sort of looking at elevation and circuits there and chemistry and hydrology. So, and lastly, just the fact that it's a growing industry with a lot of job opportunity. So it's nice to not be pushed into a corner of, oh, will I get a job? I just have to take the first thing that comes my way. I think I don't really feel that pressure coming from my program. And, I can actually look around, see what the options are, and find something that I'm really going to enjoy and be passionate about. So I'll just pass it over to Kyle.
Good evening, everyone. Hope you guys are enjoying the presentation so far. So my name's Kyle Verwey, and I was a geological engineering student up to 2010. I then actually stayed with the university to complete my master's in environmental and civil engineering in 2013. And since then, I've been back and forth to the university, but I've been working primarily as a engineer, designer, and contractor for trenchless construction and the heavy civil industry in Ontario. But outside of that, we'll talk a little bit about my co-op experience. So starting back in 2005, I had a number of co-op terms. For me, I was focused originally on staying local because I was heavily involved in the varsity program at the university. But I was also able to kind of hone in on exactly what I wanted to do with soils and construction. So I did a term with York Region Traffic Department, learned the ins and outs of how municipalities operate. And then my subsequent terms were with testing facilities. So Peter McCallum, which is a world-renowned geotech investigation company, I worked in their lab testing soils and concrete in Kitchener. And then I worked at the university for one of the departments that unfortunately no longer exists, but the Center for Advancements of Trenches Technology. That entity has been rolled into a new and improved entity called QIC, based out of the University of Alberta. But essentially, it was an advocate organization that was run by faculty of the Civil and Environmental Department that promoted the understanding and use of trenchless technologies in construction. Of great interest of that was that trenchless technologies is 10 times less impactful when it comes to carbon emissions than conventional open cut works. And then finally, for my last term, I did high-level soil testing at Inspexol, which is now part of the GHD group of companies in Waterloo, where I did triaxial tests on soil and rock samples. So while my co-op programs were mostly local, of the 14 other members of my class, I know some of them went to Africa to search for gold as a co-op program. They were in South America doing mining and geological investigation, as well as East and Western Canada, working on mining projects and engineering, civil engineering projects. So it was a great experience overall. So what I loved about geological engineering, moving up a step and taking it to where I am now in my career, you get exposed to civil, geological, and environmental engineering concepts in all of the courses you take throughout the program. And those have given me a huge advantage over someone who specializes in, for example, only civil. Getting an understanding of soils in the geological program, where it's coupled with geology and engineering, is a huge advantage when it comes to underground construction, which my field is specifically in. One of the nice parts about the environmental and geological program is the class sizes are very small, so you get to know everybody. Most of my classmates lived together. So again, we had 14 guys in our class, and there were 2 houses that housed most of the people in our classes. So it was a very tight-knit group of people. These are some photos from my 3B field trip where we went to Bancroft to investigate some of the geological formations out that way. Because of the smallest class sizes, you really get to know pretty much everyone in your class. And even still, 14 years later, I still keep in touch and not necessarily professionally work with some of these guys, even though some I do. But we're all in different fields in the geological and civil and environmental engineering fields now, and we have that kind of professional appreciation of each other and can reach out to each other if we know someone can help us out with a problem that might be better suited to someone else's specialty. So that's kind of my experience with geological engineering, why I love it. And it was a huge asset. Waterloo specifically, I came here specifically for the co-op program, which put it next level above all the other geological engineering programs in the country.
Awesome. Thank you so much. Thank you, everyone. It was lovely to hear from everyone. I know there was a lot of information there. Looks like we had a lot of great questions here too. It is 9 o'clock, so I will wrap up. A lot of great questions I see. We have a lot of great answers. Brianna's in there answering a bunch of your questions. I just wanted to comment on a couple of things. If you have any questions that weren't answered, or if you come up with any questions at the end, please email enginfo@uwaterloo.ca, and we will be more than happy to answer any questions that you do have. I would also recommend to reach out to a current student ambassador. So if you go to our website there, we have over 200 of our engineering ambassadors on our Unibuddy platform. So you can message them any questions that you have. They will be more than happy to chat with you. I would also encourage you to come to campus for a tour or an event. We do have our March break open house coming up in March on Saturday, March 22nd. Definitely come and check that out. And other than that, we do have tours all the time throughout the year. Maybe starting again in the new year. Our students are starting their exams shortly, so we will be starting those back up in the new year. But I just wanted to say thank you to all of my lovely expert presenters that were here tonight and all of you that were online for us tonight. I hope everybody has a great night, and I will hopefully see you soon.